Welcome to Web Mathematics Linear Equation Review. I'm your host, Mr. Walker, and this tutorial is meant to give you a quick review of the three most common forms of linear equations that you'll be asked to work with. The first thing I'm going to do is start with something familiar, the formula for slope, where if you are given 2 points, you can calculate the slope between those 2 points. What I'm going to do first is think about the fact, well, what if instead I actually already had the slope and I had 1 point? How many lines am I talking about? Well, if we think about that for a moment, and you have 1 point that the line goes through, and you're given a specific slope, well, there can really only be 1 line that goes through that point with that slope. So if we're given the slope and 1 point, we have already determined a specific line. What does that mean about my second point? Well, my second point is really any other point on the line. So I'm going to turn that second point into a variable and rewrite this equation as m, the slope, is equal to y, a variable, minus y1, a specific value, divided by the variable x minus x1, the specific value or the x-coordinate of the given point. Doing a little bit of algebraic work, I'm going to multiply both sides by x minus x1. And that means I get cancellation on this side, and simply rewriting the right on the left, I've got the equation y minus y1 is equal to m times x minus x1. And this is known as the point-slope form of a linear equation for pretty obvious reasons. The known or given information is a point, x1, y1, and a slope, m. And then x and y are variables. Making it pretty and nice, there is your point-slope form of a linear equation. Let's look at a couple of examples. So I have my point-slope form of a linear equation right up here, and I've got some information. I'm asked to write the equation of the line that passes through the points 3, -2, and -6, 4. Well, unfortunately, I don't have the slope. I have 2 different points, but I don't have the slope. So when we were first looking at this, we were thinking, oh, we'll just plug in the slope and the point will be done. Well, in this case, given 2 points, I can calculate the slope. So we take the typical slope formula. I like to set it up this way because I have less of a chance of making mistakes with my signs. And so I know in the numerator it should be y2 minus y1, so I'm just going to simply go with -2 and 4. So if I do that, that means this must be 0.2 and this must be 0.1. Of course, it doesn't matter which is which, but we just need to keep the -2 together with the 3 and the 4 together with a -6. Then simplifying, I get -6 over, I get a +6 or a +9 altogether, and that simplifies out to be a -2/3. So now we have a slope of -2/3 and 2 points to choose from. Does it matter which one I use? Not at all, because both points are going to be on the line because I've used them to establish the slope, so I just need to pick one, whichever one I'd like. Again, I'm going to go with 0.2 because it's right there next to my equation. So y minus y1 equals m times x minus x1. Plugging in, I know that y1 is a -2. I know my slope is a -2/3. And I know x1 is 3. And now I just want to remove some parentheses here. I get y plus 2 is equal to negative 2/3 times x minus 3. And now I have the equation I'm looking for in point-slope form. It's perfectly all right to leave that positive 2 over there with the y. There is no mathematical reason why it must always be just a y on the left-hand side. This is a perfectly valid equation. And it works even if I'm graphing. Now, if I wanted to graph this equation, it's also in a form that will make it very simple for me to do that. I'll start with my x and y axes, a rough sketch, and I know I'm working from the point, I know from this form that I have the point 3, negative 2, and I can then pick another point simply using the slope of negative 2/3. If my slope is negative, that means my change in x and change in y have to be different. They can't both have the same sign. So in this case, let's say I went to the left 3, 1, 2, 3. That's a negative change in x, so I need a positive change in y, so I go up 1, 2. And lo and behold, this line actually goes right through the origin. But there we go. 2 points determine a line. I can sketch it. So this form of an equation is very simple to sketch as well. So that's it for now. In part B of this tutorial, I will develop the other two forms of a linear equation that you're going to see.